Hello guys, welcome to Science Man. Today we are going to talk about the concept of kilogram. In the previous video, I have talked about the concept of second. Today we will talk about kilogram and some other units which are used to measure the atomic mass. Okay. So let's start our class. So what is kilogram? Right. So kilogram was defined differently previously, right? So we know that, and it was defined after meter was invented. So by the time we were experimenting about the definition of kilogram, we already got the unit, standard unit of length, and some other units like the volume of water, the volume of other liquids, etc., etc. So we know by now that 1 meter cube is equals to 1000 liter, right? So 1 liter is equals to 1 by 1000 meter cube. So if we convert this meter to decimeter, then it would be 1 by 1,000,000 10 decimeter. So 10 cube decimeter cube. So 1 by 1000 into 1000 decimeter cube. So 1 cubic decimeter. 1 liter is equals to 1 cubic decimeter, or 1 liter is equals to, if you want to define liter in terms of centimeter, what it would be? Convert meter to centimeter. 1 by 1000 into 100 cube centimeter cube. So 100 cube would be 1 2 3 1 2 3 1 2 3 4 5 6. So 1000 centimeter cube. 1 liter is equals to 1 cubic decimeter is equals to 1000 cubic centimeter. We are doing this because it will prove helpful later, or we know from this how much meter? 0.001 meter cube. So volume of water, liter, is the unit of volume of liquid. Volume of liquid. So 1 liter is equals to 0.001 meter cube, or 1 decimeter cube, or 1000 centimeter cube. From here we will get the concept of kilogram. How? At first, in 1793, the unit of measuring mass was different. It was called grave and gravet. So we don't need to talk about that. We will start from 1795, from when the concept of gram and kilogram came. In 1795, gram was defined as mass of 1 cubic centimeter of water at 0 degree centigrade. So 1795 the physicists considered gram as mass of 1 cubic centimeter of water at 0 degree centigrade, right. 1 cubic centimeter means 1000 centimeter. If 1000 centimeter is 1 liter, if 1000 centimeter is 1 liter, then 1 centimeter is how much? 1 centimeter is centimeter cube is, we know 1000 centimeter cube is 1 liter. So 1 centimeter cube is how much? 1 by 1000 liter. So liter, deci, centi, milli. So liter by 1000 is how much? Milliliter, right, because 1 milliliter is 10 to the power minus 3 liter. Liter by 1000 is 1 milliliter. So mass of 1 cubic centimeter of water or 1 milliliter of water at 0 degree centigrade was described as gram. So what was kilogram? It's very easy. If you multiply 1000 with gram, it will turn into kilogram. So what it would be? It would be mass of 1 cubic centimeter. It was the previous one. If gram was 1 cubic centimeter, if gram was 1 cubic centimeter, then kilogram would be how much? 1000 cubic centimeter, right. In case of kilogram, look, kilogram is equals to gram into 1000. So if gram was this, 1000 will be multiplied to this. So if 1000 is multiplied with cubic centimeter, so how much it would be? It would be 1000 cubic centimeter. Now from here 1000 cubic centimeter is equals to how much? 1 liter. So kilogram would be mass of 1000 cubic centimeter or 1 liter of water at 0 degree centigrade. Clear? So in 1795 this was the concept, but it will be changed in the 19th century. A slight change, not too much change, but a slight change. What will be the change? In 1889, physicists saw that the density of water turned out to be maximum not at 0 degree centigrade but at 4 degree centigrade. So they thought that very dense means what? Very dense means when the molecules are very close together. So just think about this thing, that if we measure a physical quantity whose molecules have too much space in between them, its mass will also consist of the mass of the air inside those spaces. But if the density is high, meaning that if the molecules are very close together, that means the space between each molecules are very less. So when we are measuring the mass at maximum density, we are actually reducing the error of having the mass of water of air inside those spaces, right? So that's why physicists thought that it would be correct if they measure the mass of the water at 4 degree centigrade, not at 0 degree centigrade. Why? I am repeating once again. At 0 degree centigrade, suppose these are the molecules of water. These are the space between the molecules. So these spaces are filled with oxygen and other gases. So when we are measuring the mass of water at 0 degree centigrade, we are also measuring the gases inside these spaces. Now they saw that at 4 degree centigrade, the density of water becomes maximum. That means these molecules will come close together. The space between the molecules are reduced to almost 0. So if we measure the mass now, the gases inside this space will be very low and we will get a very accurate value. That's why scientists chose water not at 0 degree centigrade but 4 degree centigrade. I think it is clear now. So in 1889, the definition of kilogram became the mass of 1 liter of water at 4 degree centigrade temperature. So this was the amount that was taken, right? After that, what happened? After that, you guys know, if you guys saw the previous videos, you guys know that a particular procedure is done after the actual value is granted all over the world. So after this measurement was granted as an accurate measurement all over the world, a replica was made from this. What was the replica? The replica was a solid cylinder of platinum iridium alloy with 90:10 ratio, right? So what they did, say they kept a 1 liter of water at this side at 4 degree centigrade and measured replicas of platinum iridium alloy on this side, and when one of them equaled the weight of 1 liter of water at 4 degree centigrade, this platinum iridium alloy was taken as the perfect replica, right? This replica is kept in Paris, right, in International Bureau of Weights and Measures. Just like they did with meter and second, that as they have the perfect value, they can define the value with another perimeter which is universally constant, right. So now currently it is defined with the Planck's constant, but this is a lecture of class 9, so you guys don't need to know about the Planck constant or how it works. You just need to know that currently kilogram is measured with E is equals to mc square is equals to hc by lambda with the help of this formula, where this h is called Planck's constant, right. So this value now gives us the value of kilogram, which is exactly the value we have measured with this procedure, right. So I guess the concept of kilogram is clear now, right. So now we will define another measuring unit which is used to measure very small amounts, like on the level of atom. So we will define the atomic mass unit which is used to measure the mass of an atom, right. So let's begin. So atomic mass unit is nothing but a measuring technique to measure the mass of various atoms with respect to carbon 12 atom, right. So it is not much different from measuring mass of other physical quantities, large quantities. Let's discuss. So suppose this is an object of 12 kg mass, right. We know the mass of this object, and here is another object, we don't know the mass of this object. So we have to measure, we will measure the mass of this object with respect to this object. So for that what we do is let's divide this object into 12 parts, 12 equal parts, 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8 9 10 11 12. So if these are 12 equal parts, each part is 1 kg. If one of these part is taken out and then with the help of when this object turns out to be having the equal mass of this 1 kg object which is taken out from this, we can say that the mass of this object is equal to this piece which was taken out from this 12 kg object, and the mass of this object turns out to be 1 kg. So we know now that the mass of this object having unknown mass is 1 kg. So now if we write this, how will we write in terms of this? So let's assume this is object A and this is object B. So we have to write that mass of object A is equals to 1/12 of the mass of object B. So this is also the procedure followed to measure one atomic mass unit. How? Let's see. So we take a carbon 12 isotope. This is a carbon 12 isotope, suppose, and divide it in 12 equal parts. Each part, mass of each part is called one atomic mass unit. So one atomic mass unit so 1 AMU or atomic mass unit is 1/12 of the mass of a carbon 12 isotope, right? So this is defined as one atomic mass unit. This is measured to measure the mass of other elements like oxygen. So what does this mean? This means that mass of one C12 atom is equals to 12 AMU, right? So 12 AMU means 12 times the mass of 1/12 of the mass of carbon 12 isotope. Similarly, mass of oxygen atom is equals to 16 AMU means oxygen atom's mass is 16 times the mass of 1/12 of the mass of a carbon 12 isotope. Meaning, if a carbon 12 isotope is divided into 12 equal parts and one part is taken out, then an oxygen atom's mass will be 16 times greater than that small carbon 12 isotope's part. This is the meaning. But is it really possible to measure the mass of a single atom like this? No, it is not possible. This is theoretical. So for that, physicists came up with a new way. How? They took the help of Avogadro number, which is the concept of 1 mole. 1 mole means Avogadro number of atoms, right? 1 mole means 1 mole of carbon 12 atom has 6.022 into 10 to the power 23 number of atoms, right? 1 mole of carbon 12 atom has 6.022 into 10 to the power 23 number of atoms, and when this much element was measured, then in each case it gave the same numerical value of the AMU, right? Like what? Like 1 carbon 12 atom's mass was 12 AMU. Then it was measured that 6.022 into 10 to the power 23 number of atoms of carbon 12's mass will be 12 gram. The numerical value was kept same for the measurement purposes. This is how they converted AMU to a standard unit of 12 gram. They said that the 1 mole of this atom will give the similar numerical value in grams, like 1 carbon 12 atom is 12 AMU, 1 hydrogen atom is 1 AMU, 1 oxygen atom is 16 AMU. So the physicist or scientist said that if we convert this into Avogadro number of atoms or 1 mole of atoms, it would be 1 mole of carbon 12, 1 mole of hydrogen, 1 mole of oxygen, meaning 6.022 into 10 to the power 23 number of atoms in all of them. It would generate the same numerical value of grams, 12 grams, 1 grams, 16 grams. So now it would be very easy to measure the mass, as we have calculated the value in grams. So as 6.022 into 10 to the power 23 number of C12 atom has a mass of 12 gram, right? Why? One C12 atom's mass is 12 AMU, right? So 6.022 into 10 to the power 23 or Avogadro numbers of C12 atom would be 12 gram. So 1 gram of C12 atom would be how much? 1 gram of C12 atom would be 6.022 into 10 to the power 23 by 12 number of carbon 12 atoms. It gives 0.5018 into 10 to the power 23 number of carbon 12 atoms. This is 1 gram of C12 atom. If we gather 0.5018 into 10 to the power 23 number of C12 atoms, it will give us 1 gram of C12. Now we convert it to kilogram, meaning we have to multiply it with 1000. So 1 kilogram would be 0.5018 into 10 to the power 23 into 10 cube. So it would be 5.0188 into 10 to the power 25 number of C12 atom. So look, this is very important. Here we have achieved another definition of kilogram. So what is kilogram? Another definition would be 5.0188 into 10 to the power 25 numbers of C12 atom is 1 kilogram. So the definition of another kilogram definition would be 5.0188 into 10 to the power 25 numbers of C12 atom mass of 5.0188 into 10 to the power 25 numbers of C12 atom is 1 kilogram. This is another definition of kilogram, right? This is very important, write it down. So from here we can also calculate the weight of mass of one carbon atom, right? From here we will calculate the mass of one carbon atom in kg. Let's see. So 1 kg is 5.0188 into 10 to the power 25 numbers of C12 atom. So weight of mass of one C12 atom, mass of one C12 atom is equals to 1 by 5.0188 into 10 to the power 25 kg, right? So we have the mass of one C12 atom. So if we have the mass of one C12 atom, now we can convert 1 AMU in terms of kg. How? Because we know that 1 AMU is equals to 1/12 of the mass of one C12 atom. Mass of one C12 atom. So now we have the mass of one C12 atom. So put it there. 1 by 12 into 1 by 5.0188 into 10 to the power 25, right? So it gives 1.6605 into 10 to the power minus 25 kg. Calculate this, it will be this value. So the numerical value of one atomic mass unit is equals to 1.6605 into 10 to the power minus 25 kilogram. This is the concept of one atomic mass unit. This is used to measure the mass of various atoms of elements, right, on an atomic level. Mass of atoms. So I hope this is clear. If there is any confusion, you guys can ask me on the comment section of the video. Okay, so this is for today. See you in the next video.